talked about energy the other day. I was going to talk about a different subject today, but some issues came up, and I thought I had to, go back and cross all the T's and dot the I's, okay? Some people seem to have lots of questions. Now, what did I say? In general, very simple, energy is not a physical object. Okay? Energy is a mathematical concept. Therefore, you cannot say that you're going to transfer energy because in physics, the word transfer has to be taken literally. Okay? So you can transfer a box, you can transfer a rock, you can transfer a tree, you can transfer a house or whatever. It has to be a physical object. Then you can talk about transferring in physics. You cannot say you're going to transfer a concept such as love or intelligence or data or information, and certainly you cannot transfer energy. We're done. That's it. That was in a nutshell. If you didn't understand that, well, you're a religious fanatic. You're a person who has memorized stuff in college. The word energy was shoved very deep into you, and your whole religion collapses without it. And that's why you're going to defend that word to the end of your life, because otherwise your life is meaningless. Okay? You have no theory, you have no explanation because you rely on that spiritual word. Okay, so some people raise some issues. Let's look at those. And some are questions, some are comments. So here it is. Okay, one fellow says, in physics, energy is defined as the capacity. Is there a physical object called capacity? Can you draw a picture of a standalone object called capacity? And the answer is no. Can you touch capacity? Can you see capacity? No. You can't see or touch because there's nothing to see or touch, assuming you use the definitions of mathematical physics, so it dies there. And in rational science, capacity is a concept. There's no issue with that. And so if it's a concept, the question is, can we talk about transfer? Okay, again, physically transferring. And so fellow says it may exist. Well, not in science. In science, only objects can be said to exist. Concepts do not exist. Okay, so that ends there as well. To say energy hasn't been defined is ludicrously absurd. Okay, well, it has been defined. And in fact, the fellow defined it there, capacity. That's how it's defined. In fact, the big problem really is this one. Let me show it to you. It's that it's defined in several ways. That's the big problem. It's a quantitative property. It's, again, capacity and ability. It's taken to be a thing because they talk about transferring of energy. It's equated to mass in Einstein's famous equation. And here's just an example, the Lagrangian. It's defined as a kinetic minus the potential energy. And they have all these other categories. Okay, energy is defined as a concept but treated as a thing. What is a thing? It's that which has shape. What is a concept? Well, that which doesn't, in a nutshell. Okay, that's the quick version of the word energy. And here you see it, okay? You see what mathematical physics, all these types of energies, they have mechanical, electric, magnetic, gravitational. I like the next to the last one there, the rest energy. I mean, what is the rest energy? Okay, and yeah, it's the one that uses rest mass, which is another irrational concept. What do you mean rest mass? Hopefully mass is always rest because mass is the quantity of matter, and all you have to do is count how many atoms you have in a rock. And then you know what the mass of the rock is. It's a gazillion atoms. That's what the mass would be. But that's not how they do it. They talk about rest mass because they're really talking about what? They're talking about gravity. They're talking about weight. And they call this mass, they call it weight. They call this weight, they call it mass. And mathematical physics has, rest energy, which is, again, it's weight, which is pressed against something when it moves. And when it doesn't move, it just, has quantity of atoms. And that's the rest energy, more or less. Okay, so yeah, but see, this is the same thing they had in traditional religions where they use all these words that are more or less synonyms of energy. You have soul, spirit, conscience, mind, thought, etc. And these words are the ones religious people use. They talk about all these words and they think that these words represent physical objects. Well, not in science. And there's nothing different between mathematical physics and traditional religions. They take all these concepts and they turn them into physical objects and then begin to move them around. That's the big problem, okay? Okay, so give me a second here. Let me take this out of here. So this is where the problem is. The problem is that, well, let me continue here. This fellow says also, transfer of energy is the conversion. He's going to explain what transfer means, okay? So he's going to go into this rigmarole. It's not that transfer is what everybody understands by transfer. This is transfer. I have a little ball, and I'm going to transfer it to this hand, from the left hand to the right hand. That's called transfer. That's transfer in physics. Okay, very simple, very straightforward, baby-like kindergarten stuff. Okay, no mystery. That's what transfer means. But here they're going to give you the runaround because they have to show you what transfer really means. Transfer of energy is the conversion one form of energy into another. So that's what transfer means, according to these people. And I like the next one. It says, or the movement of energy. See, so they take this concept, they define it as the capacity, and now they're going to transfer the capacity, and they say, we're going to move the capacity. Here, I'm going to move it. Yeah, so they use these figures of speech, okay? That's what they're doing. That's what they're introducing, figures of speech, of ordinary speech, and, euphemisms. And they want to do their theories with these euphemisms. No, that's okay. I mean, if you want to use poetry, no problem in your presentation. Like at the end of your presentation, when you do your closing arguments, yeah, you can use poetry, you can use figures of speech. It's okay to play around with the words. But when you're giving the core of your theory, when you're giving an explanation of a mechanism, that's got to be literal. That's got to be literal in physics. You got to say, look, here's the ball. Give me, take a ball. Say, here's the ball, and I transfer it. That's called transfer. You can't say, well, what I really meant. No, not in physics. You can't use euphemism. You can't use figures of speech and say, well, it's really a conversion of one energy into another. So far, you said absolutely nothing. All you did was hide the fact that you don't know anything about physics. That's what you did. Okay, here's another fellow, and he says, energy as a concept might not have a place in explanatory physics. I thought that's what physics was all about, 150% of it. Isn't explanatory physics that actual physics? I mean, isn't explanations of mechanism what physics is all about? What else is physics about? You have to explain how this universe works. You have to explain gravity. You have to explain how magnetism works. You have to explain, how the atom works. That's what you got to explain. So that's what physics is about. You can't use the word energy for that because you have to use objects to do that. To explain a mechanism, you need objects. You can't do it with concepts such as, energy. But he says, it's not a spirit. Well, it looks like to me, I mean, the capacity, what is that? Is that a physical object? If it's not if it's not a concept, it's an object. And if it's not an object, it's a concept. There are no other categories in the dictionary. Either it has shape or refers to that which has shape or refers to that which doesn't. In other words, to a relation between two objects. That's it. There are no other categories. God is either a physical object or God is a concept. Love, grace, whatever. God cannot be both. Okay, that's the issue. In physics, for the purposes of physics. In ordinary speech, you can say whatever you want. Okay, the gas in my car has the capacity to make my car work. So I can say that gas is an instance of energy. No, gas is not energy. Gas is gas and energy is energy. So let's point to this fellow where he's going wrong. Okay, gas is a physical object. Okay, it's an object. Energy is a concept. Energy is not equal to gas. Gas is not equal to energy. You must define the word object, the terms, the categories, object and concept before you talk. Otherwise, you're going to get into the circular reasoning. Okay, energy is not equal to gas. Okay, gas. What is gas? Gas is made of atoms. It's finite. It's single frame. Okay, you can take a snapshot of gas, especially one that's visible. We can't of those that are invisible, but maybe you could do it with some ultraviolet light or whatever. But energy, you can't take a picture of because energy is a mathematical concept. It's a magnitude. It's got units. Okay, so energy is totally different than gas. Okay, so that's what's wrong with that. Okay, so you cannot have what he says there. We can't have an abstraction to why can't we have an abstraction to describe things? Well, because science is not about describing. That's the issue. Science is about explaining. That's what you got to do in physics. And you can't say, well, gas is energy and energy is gas, because all you're doing right there is talking about words of ordinary speech. We say, oh, put some energy in your tank. Yeah, that's okay in ordinary speech. You can't use that terminology in physics. Okay, that's where the problem comes in. And people don't understand that. They bring all this language from ordinary speech because the mathematicians do. And so they say, well, the PhD there from Harvard, he used the word energy over here and he used it over there as well. Yeah, they do because they never did physics. Physics has to do with physical objects. You can't do physics without a physical object. You need an object. And you can't move concepts around. You can move gas around. Gas because, just very simple, it's made out of atoms. Okay, so if it's made out of atoms, it had better be an object because one atom is an object. It's a thing. It's got shape. Okay, and if you take a bunch of atoms, gas, and you put it in outer space, if you could had the eyes of God, you could see, for example, air. It would have shape. It's a blob, an irregular shape, but it has shape. You can't do that with energy. There is no physical. What are you going to put out there? What is energy made of? Atoms? More energy, spirits, what is it made out of? No, energy is a concept, a mathematical concept. And it's been driven so deep in people's mind that, energy is a physical object, that it's transferred, that gas is energy and so on, that they can't get out of that. They're in this religion, they're hypnotized to believe, energy is an object and is treated as a physical object. Not the case, okay? Okay, another follow-up. Lots of people have problems with this, okay? bgaede defined energy as a curse word. That is religion, not science. Okay, first of all, I didn't define it. See, I don't use the word energy except when I want to relate to what the mathematicians call energy in terms of the rote model. That's the only time I just want to show people what these people are talking about when they talk about this concept called energy. Then I put it in terms of the rote model. But we don't use the word energy at all in physics. Okay, the word energy belongs strictly to the religion of mathematics. Okay, so we don't use that word at all. It's used by the mathematicians because they are concerned not about explaining, they're concerned about describing. They need to put a number and units in an equation. That's the proper place for this word energy. But we have a problem because they give you the physical interpretation of that, and they say, well, we transferred the energy or whatever. Okay, and we transformed the energy from this kind of energy to that one. Like if they were using silly putty or, whatever, and building a statue with, I'd say we transformed the silly putty into the statue. That's more or less what they try to convey to you when they say, well, we took potential energy and turned it into kinetic energy, or they took chemical energy and turned it into kinetic energy. They're trying to say that they molded this energy and turned it into something else. And all they're doing is talking about really equations. They're saying that we turned this type of energy, meaning a number and a unit, into this type of energy, meaning this number and unit. So this is where you have to grasp that, because unless you understood that, you don't understand what conversion of energy means, or what transfer of energy means. Okay, and I didn't define it, but here you have different notions. One notion that mathematical physics has is that energy is the capacity and the ability. That's how it's defined in most dictionaries. Then you find this equation: E equals mc squared. Energy equals mass times velocity of light squared. Einstein's equation. So you have these different notions. What does capacity have to do with that equation? Okay, capacity is a different definition. I mean, are we talking about a definition here, or is this just an equation? I mean, is an equation a description? Is an equation just a tautology? What is that? Okay? I mean, can we say those two are equal? The fact that you define something with words and say it's a capacity, and then you put an equation and say these two things are equal? This is the issue. And then another notion is that energy is not equal to not an object. Energy is a concept, and you can't transfer concepts. So again, I didn't define this word, and I don't use it like that. It's the mathematicians who do this. So if anything, the curse word is the one that they introduced, not me. Okay, and just the bottom line: any use of the word energy as a thing, such as in transfer energy, converts to mass, etc., is irrational. You can't use this notion in physics. And people have problems again because, if ever you destroy the word energy, you destroy their religion. It's the most important word of mathematical physics, energy. And again, it's spirit. Whenever you don't understand something, you introduce the word spirit and says, oh, the spirit moved the curtain. The spirit is the one that came and talked to me at night. And as long as you don't, you treat spirit as this soul, that comes out of you, and you treat it as a physical entity that has mass, weight, shape, walks, talks, well then, then we have a problem because we can't follow what you're saying. I mean, what is this spirit that you talk about, paleface? Okay, and it's not me who doesn't understand. Here he says, we aren't allowed to use energy anymore because Bill can't figure out what it is. No, it's not me, it's Feinstein who doesn't know what it is. He says, it is important to realize that in physics today we have no knowledge of what energy is. Feynman couldn't figure out that he was talking about a concept. So you can't use the word what in the context of energy. Energy is not a what. And another fellow also along the same line said, Ricky's sentence is correct. The language used is grammatically correct. Okay? He correctly used the words what is to correctly express his thoughts. We have no knowledge what energy is. And he sends me to a link. He says, listen to this music. And the music is called What is Love? And again, in ordinary speech, you can say, what is energy? In ordinary speech, you can say, what is love? Not in science, not in physics. In physics, there is no such thing as love, no such thing as energy. Okay? And so that's what we're referring to. You can only use the word what in the context of objects. You can say, what is a tree? Okay, and you point to it. And you say, what is a dog? What is a rock? Then, and you point to it. Then you can use the word what. But you cannot say, what is intelligence? That's an irrational statement in physics. In ordinary speech, you can ask that question. You can use whatever you want, and nobody's going to pay attention to the language. And you'll say it's grammatically correct. In science, it's not correct. It's irrational. You can't say, what is intelligence? What is information? What is soul? What is conscience? You can't ask that question. It's irrational. It's an irrational question. You can only ask, what is a thing? You know, what is a tree? What is a rock? And the answer has to be, you point to it and name it and say, that's a rock, that's a tree, that's a house, that's a dog. That's how it's answered. You have to point and name. That's the only answer allowed. Okay? Now, concepts we define. So you have to say, give me the definition of such and such word. And you either point and name objects, or you define concepts. Okay? So you can't say what is such and such concept, not in physics. So you have a different language in physics, okay? So you need to know the difference between an object and a concept before you use the wrong terminology to even ask the question, okay? So no, in physics, it's not grammatically correct to say, what is energy? Fellow says, to transfer means to move from one place to another. To move and to transfer are synonyms, okay? Like that. So essentially it means to change location. Okay, I like that too. The energy changes location. So he takes the energy from here and moves it over there. All these words, they move, you know. It's very scary stuff. They move the energy. So this is the problem. People treat it as a physical object. They think they can transfer energy. They think they can move energy from one location to another. And they're talking about mathematical amounts and units. That's what energy is. Energy is a concept, a mathematical concept. You don't move number fives. You don't move meters. Okay, or whatever, joules or, you know, KEVs. Okay, another fellow says, keyword transformation. Okay, keyword turn into. The object had a translation. It moved. So again, these people are moving concepts. They believe that energy is a physical object, and they use these euphemisms. We transformed it. And what do you mean by transform? Well, we moved it, we transferred it. And what do you mean by that? Well, we converted it. And so they use all these euphemisms instead of saying, look, this is very simple. This is the object here, I transferred it. Okay? That's called the transfer. And transformation, you know, I can take, clay and turn it into a statue. Then I transformed the clay into a statue. That's how we use the words in physics. You can't say you're going to transform a concept. That's where these people go wrong. Okay? And again, you know, we can create concepts all the time. I create them every day. In fact, ask any programmer out there, they constantly create concepts, because what they're really doing is, imagining new terms, new concepts out there. And you know, they say, we created a concept. But see, that when you create a concept, it's not the same thing as to create an object. We have to be very careful with using the word create, because we say, well, we create things every day. Yeah, we create concepts, okay? And we do not create objects, meaning take nothing, absolutely nothing, empty space, vacuum, and suddenly produce length, width, and height. Produce a shape out of nothing. Not even God can do that. And you might say, well, how do you know? He's all powerful. Yeah, all you have to do is explain the mechanism, the process, how he transformed nothing into something. Just if you can explain the mechanism, be great. If you cannot explain the mechanism, don't tell me that God can do it. God can come here and tell me, okay? But don't you try to tell me that, okay? Because all you're telling me is you believe that. You have to explain the mechanism if you want people to understand you, let alone believe you. And right now we can't understand you because you say you don't know how God does it. Of course not. You cannot even imagine something popping in from the void, spontaneously, surreptitiously. And so, yeah, not even God can create something from nothing. And, it's one of those issues that, you cannot avoid. You have to explain. Otherwise, your statement is worthless. All you're telling us that you believe in magic. That's all you've told us so far. Okay, here's one fellow. He says, energy is not a concept. Oh, one guy who objects to treating it as a concept. We point to it. I'm pointing to energy, okay? I point to the delta. The delta? What do you mean the delta? What's a delta? letter D, Greek letter D, is that what delta is? It says, I point to the part of the image that change between the frames of the video. So we have there a video, right? And we take two frames. We have 505 and 506. You can look at another two frames if you want. And he's pointing to the delta, to something between them. I don't know. There's no frame in between. But he says that he's pointing to some kind of frame that's in between two adjacent frames. So I don't know what he's pointing to, what this delta thing is. But he says, I'm not pointing to the change, okay? I'm pointing to the delta. Goes back to the delta, okay? The difference between. So he's got to talk about a difference. He's saying that delta is this difference. I guess that's what the word letter D stands for, difference. So you're going to point to the difference. Well, difference is not a physical object. There is no physical standalone object called difference. Okay? And so I can show you the energy between your start of the video and the end of your video. The difference between the snapshots are your energy. So he's saying the difference is the energy. I hope someone understood, because no one can understand it. At least I can't. Okay? Okay, here's an example. Okay? Here's Bill when he was 2 years old, and Bill at 20. And that's 18 years difference. I guess that's the delta. And, it sounds like a Rico sentence. No, Your Honor, I'm not a racketeering guy. I was a communist. Same difference, son. Okay. Your Honor, I can't do 18 years. I'm 84 years old. I can't do 18 years. Well, sir, you do as many as you can. What the hell is this delta? I mean, are we talking about 18 years? Is the beginning of one frame and the ending of another frame in my movie? What the hell is this delta? I didn't see any energy. I just saw two pictures. Where was the delta? Okay. And I can show you energy between your start of the video and the end of your video. Well, where was it? What is it, the 18 years? Is that what the delta was? I mean, I don't know. Maybe someone smarter than me can figure it out. Okay, I don't understand this fellow at all. Okay, and here's another fellow says, and the day after Veritasium utters this nonsense. And another fellow points to the same video. He says, thought this might amuse you, relates to what is electricity. So talking about pointing at deltas, well, this guy brings up John pointing. Okay, and pointing came up with a pointing vector. What was that? That represents the directional energy flux, the energy transfer of an electromagnetic field. And so if you take the standard electromagnetic wave, the transverse wave, James Maxwell's wave, well, you have this electric field, which is a bunch of vectors, abstraction again. And then you have the magnetic field, which is also a bunch of vectors, another one that's running apparently perpendicular to one to the other. Okay, and they move, and energy, according to Poynting, John Poynting here, this fellow, moves perpendicular to both. Here you have, electric field, and this is your magnetic field. Then towards your eyes, what you have is the energy flow. Energy, meaning, the photons, they flow into your eyes. That's the energy you're getting from the sun. That's essentially what the notion that John Poynting came up with. And he says you can apply that also to electricity. That's going to be this Muller's Veritasium. That's going to be his argument. He's saying, yeah, just like we did it with light, electromagnetism, right? We can do it also with electricity. And that's going to be his point in that video that had almost 5 million hits. Okay, let's see what he's going to talk to us about, what this fellow Muller's going to tell us. And he says the following, okay? He says that, again, energy flux is perpendicular to magnetic field and electric field, and he's going to replace those really essentially with electricity. So he's going to do the same thing that he did with light. He's going to do it with electricity. Okay, so that's his argument, and these are the two questions that he's going to try to answer. Okay, here it is. Okay, he says, if the flow of current is two ways, okay, current, remember you have alternating current, goes in one direction, then goes in the other direction. So when the power plant produces electricity, it produces alternating current, okay? And so it goes to your home, and then it also comes back to them, and it goes back and forth, constantly. That's the notion we have, right? And so if flow of current is two ways, okay, he says, then why does energy flow in one direction? Yeah, good question, okay? And the issue is here, he says, when those same electrons flow back to the power station, okay, why are they also not carrying energy back from your home to the power station? Because you wouldn't have to pay, I guess, any energy if you provide the power station back with the energy they gave you to begin with. Be great, right? You'd have zero electric bill. So are you sending electricity or energy back to the power station? Well, he says, no, it only flows to your home, but not from your home to the power station. Okay, so it flows one way, even though electricity flows both ways. Okay, the alternating current. So see what his argument is. That's what he's going to try to show you in his movie, his video. Okay, let's see where it leads. So he starts out by doing this. He's going to start by explaining to you a little bit of what electricity is. And he already bombs out here because he says, you know, you have the flow of electrons, which he's later going to say electrons don't really flow, like, you know, going all around. He says they move very little. And in fact, in alternating current, they go just very little back and forth. That's all. They just shake back and forth, which is not what he's showing there. There he's showing a single motion of the electrons, direct current, I guess, right? But the current flow, he shows it in the opposite direction. And he says, well, it's conventional flow. You know, the conventional electricity has a different direction than the electrons. And so we have a problem because he's already confusing us. He's saying, look, the electrons go in that direction, which he's later going to say they don't because they go back and forth. They just vibrate like back and forth in situ. That's the first issue. And then the other one is that he's showing that they're flowing, but then he's got the current flowing in the opposite direction. Very confusing stuff. And he doesn't clarify that. He just continues, right? Okay, so we start off on the wrong foot because what he's explaining doesn't match what he's illustrating. That's where we start off on the wrong foot. But that's the least of his problems. It just gets worse. Here it goes, okay? He goes into and shows this. He says, look, when the electrons flow, they create this electric field all around the circuit, okay? And so it's all around the wires, okay? So this electric field is going to be important because, you know, he's going to use this to show that it's this field that's eventually going to move the electrons around. So the movement of the electrons creates a field, and the field is the one that moves the electrons around. We have a circular argument there. We don't know which came first, the chicken or the egg. Okay, so that's his starting point, which again, not very rational. But this is where we have a problem. Okay, here's the electric field pushes electrons around. What do you mean the electric field pushes the electrons? I thought the electrons created the electric field that extends throughout the circuit. Okay, so again we have this contradiction in understanding in the language that he uses to express himself. Okay, and again what he talks about does not match what he's illustrating. Okay, so we continue. Here's he's going to try and explain this pointing vector because he's going to say that, remember, the electric and magnetic fields are perpendicular to each other, and the energy, right, travels perpendicular to both. Remember that. That's important. Okay, he's going to show that the pointing vector, in other words, the energy, travels perpendicular to both the electric field and magnetic field, which is what they claim happens with light. He's going to show the same thing for electricity. I want to reinforce that, okay? Okay, so he says the current inside the wires creates a magnetic field outside the wires. Well, it also creates a magnetic field inside the wires, for that matter. I mean, you can see the circles, the blue circles, they go inside the wires as well. So it's not only that they create a field outside the wires, it creates it inside the wires as well. That's the first problem. The second problem is that he talks about the right-hand rule, but he's going to use the left-hand rule. Look at the motion of the electrons. Okay, the electrons are moving, in this case, counterclockwise. Okay, you can see the green ones going around the circuit. And what he's going to say that these electrons, as you can see, he's going to use that top hand, which is the right-hand rule, but he's actually illustrating the left-hand rule, which is the electrons going down and the magnetic field curled around in the direction of his fingers. So he's using the left-hand rule and he's calling it the right-hand rule. So again, we have more problems here because what he's illustrating doesn't match what he's saying. But he says, according to Poynting's theory, energy should be flowing, and then he can figure out the right-hand rule. Okay, this is what he's trying to say. Let's go over that slowly so that you can see what he's doing here. Here's let's stop the picture there. Okay, you can see what's happening. You can see his fingers are curled. Look at how his fingers are curled. Okay, that's important. Okay, here you have first. This is the electric field there. Okay, it's moving downwards in the circuit. So both thumbs are downwards. So far, we're okay. Okay, the electric field is okay. How about the magnetic field? Well, the magnetic field is running in the opposite direction. Okay, because the magnetic field is moving. If you look at it from the bottom, it's moving clockwise, and what he's showing is counterclockwise with his fingers. Okay, he's moving. His fingers are curled in the opposite direction of the arrow that you see in the magnetic field, and this is going to become a problem because here's the energy flow. Okay, and the energy is flowing parallel to the magnetic field. He wants to give you the idea that the electric field is going down, whereas the magnetic field is coming into your eyes, and energy is flowing perpendicular to both. Actually, the magnetic field is going all around the wire, and if you look at it from the side, it's going to go into your eyes. If you look at it from behind, it's going to go into your eyes. And if you look at it from the left, it's going to go into your eyes. No matter how you look at it, that magnetic field is twirling around the wire. So the energy flow is going to be parallel to the magnetic field. It's not perpendicular as he originally said he was going to prove. That's the point I'm trying to make. Okay, so let's look at what happens at the battery. Okay, the battery, he goes into more of the same thing. Okay, he's again going to call it the right-hand rule, but he's actually, talking about the left-hand rule. In other words, the illustration doesn't match what he's saying. And there you see, we go close to the battery, and you can see the direction of the electric field. He says the electric field is downwards. The magnetic field is into your eyes, which is not true. It's all around. It's not into your eyes, because if you look at it from the right, it's also going to go into your eyes. If you're going to look at it from the left or from behind, it's also going to go into your eyes. No matter how you look at it, it's going to go into your eyes, and that means that the energy flow is going to go parallel to the magnetic field. And that's aside from the fact that he's got the right-hand rule when he's illustrating the left-hand rule. Okay, so he's got two problems there. And here, let's stop that so that you can see it. Okay, that's what it looks like. Okay, you see the magnetic field is into your eyes, supposedly. Electric field is downwards, and energy is to the right. Okay, and that's not really what he's showing with his hand there, the one on the right. I put the correct hand on the left, which is the left-hand rule, and you can see that matches exactly what he's illustrating. Okay, so yeah, we have a problem with what he says with respect to what he illustrates. It's very confusing. And again, people don't catch these things. They just bow and say, yeah, okay, I understood, when they didn't understand squat. Okay, so here he goes into a little more detail. He says, look, then we can show that the energy flows in one direction, okay, which is from the battery to whatever receives it, the lamp or whatever's on the other side, which is what he's trying to show with the power plant. He says the power plant gives you energy, but you don't give it back because the flow of energy is one way, okay? And so he says the transfer of energy along the way, you can use the right-hand rule to find the energy is flowing to the right, okay? And on the top is the same as on the bottom. They flow to the right, okay? And so, yeah, I don't know. Here's a little more detail of that, maybe. Okay, you can see, it says it's the field, not the electrons that move. Well, let's start here. It says even though the electrons go two ways away from the battery and towards it, okay, by using the pointing vector, you can find that the energy flux only goes one way. Okay, and it's the fields and not the electrons that carry the energy. Well, we have a problem here, because what he's saying is that the reason, the cause, the mechanism, right? That's what we're trying to explain here. The reason energy goes to the right is because of the pointing vector. That's not an explanation. That's saying, look, the reason Poynting came up with this vector is he went out there, he looked at this, and he says, okay, I'm going to come up with my vector saying that energy flows in this direction. Okay, so that's a description. Now they're going to use that description to prove or to explain the mechanism of why energy flows to the right. And that's not an explanation. That's just a regurgitation of Poynting's vector. So he hasn't explained anything. All he said is, energy goes to the right because it goes to the right, because the Poynting vector says so. And Poynting got his mathematical description from observing a circuit and say, well, yeah, energy always flows to the right. So he hasn't explained anything. So not only do we have a problem with the fact that this fellow, Muller, does not illustrate what he says, or does not state what he's illustrating. He's not describing that. That's one issue. The right-hand rule, he's illustrating the left-hand rule. That's one issue. But the other one is he's using the Poynting vector to explain why energy goes in one direction. And you cannot use an equation to explain something. You have to explain physically why energy, whatever energy is flowing in one direction, which is what he was trying to prove from the start, saying, look, the energy comes from the power station to your house, but it doesn't go back. Well, why not? We still don't know. Well, it's because of the Poynting vector. And it points, Poynting vector. He knows that energy, according to the Poynting vector, goes one way. But that's not an explanation. That's just saying, we verified in the lab, by running experiments, that energy flows in this direction. And why does it flow in that direction? Because of the Poynting vector. What is the Poynting vector? Well, it's a mathematical description of energy flowing one way. That's why it's called a vector. Okay, so let's get down to the conclusions with all this energy nonsense, okay? Laymen routinely confuse energy for a physical object. That's a big, big problem. And again, it's laymen, people who have very little understanding of physics. Energy is a mathematical concept. In other words, you can't transfer concepts. You can't say you're going to transfer energy. And again, it's a fight between ordinary speech versus scientific language. You cannot use euphemisms or figures of speech. You have to use the real McCoy. If you're going to talk about transfer, you have to talk about objects only. You can't say that you're going to transfer a concept. Veritasium Derek, this fellow Muller, uses ordinary speech that he memorized in college to make his case. Very Derek has energy parallel to the magnetic field when it should be perpendicular to it. Very Derek illustrates left-hand rule and calls it the right-hand rule. Very Derek hasn't explained the cause of energy flow in one direction. All he said is it's because of the pointing vector. And Very Derek hasn't explained why the cause, the mechanism, energy from your house does not go back to the power station in the enormous closed circuit. And what's interesting, his video received almost 5 million views that I saw it this morning. He put it out on my birthday, November 19, 2021. Thank you, Mr. Derek. And there were 248,000 up fingers out of that 5 million. Interesting. That's how many people did not catch any of this. They just golfed, they just went in there for entertainment, and that's all they did because they didn't understand squat of what Derek was trying to explain. So my corollary, Veritasium Derek memorized what authority fed him in college to obtain his PhD. He never questioned the catechism. Very Derek's PhD is worthless. It's just a piece of paper that's not worth the paper it's printed on. He has not explained why energy flows one way. A description is not an explanation. Pointing's vector is only a description, a mathematical description. That cannot explain to you the cause of why this mysterious thing called energy, which is a concept, flows from the power station to your house and why you get a bill every month.